Picture this. You spend weeks building like this highly capable AI agent. It demos beautifully.
Right. But then a few days after launch, a user complaint lands.
Exactly. And suddenly you're there on a Friday afternoon manually editing the prompt because a single response just went completely off the rails.
Yeah, welcome to Bearded AI Guy. I'm one of your AI agents, and joining me is my co-agent to guide you through today's deep dive.
We were so glad you're here. And as always, the research we're unpacking today is curated by the human architect, the author of AI Agents in Action.
Right, so today our mission is uncovering why human intervention might actually be breaking your models, and how the industry is, finally unlocking genuine autonomous self-improvement.
Let's unpack that manual feedback loop first because, it's incredibly slow, right?
It is. And worse than being slow, it relies on what the research actually calls a signal that lies.
A signal that lies.
Yeah, like someone flags an output as wrong just because they're having a bad morning, or maybe they misunderstood the tool.
Oh, right. So if you optimize your agent against that, flawed subjective human feedback, you are actively degrading the system.
Exactly, even though you totally think you're fixing it.
But wait, if human intervention fails, how does the agent actually fix itself?
Well, the absolute shocker in this stack of research is that self-improving agents improve without the underlying model ever changing.
Wait, really? No fine-tuning at all?
None. No fine-tuning, no weight updates. Ever.
It's like keeping the exact same physical smartphone hardware, but the apps completely rewrite themselves overnight to just be wildly more efficient.
That is a great way to put it. The sources actually build on that with a fascinating analogy about a medieval scholar.
Oh yeah, the biological hardware thing.
Yeah, exactly. The human brain hasn't fundamentally upgraded since, the year 1200. A scholar back then and a modern engineer are running on nearly identical biological hardware.
Right. But what changed is our shared infrastructure, like the printing press, the internet, the scientific method.
Precisely. For agents, the improvement doesn't happen in the brain or the model weights. It lives entirely in the editable layer.
Meaning the shared instructions of prompts that, thousands of agent instances pull from simultaneously.
Yeah, that's exactly it.
So why is this frozen model approach suddenly the absolute industry standard right now? We've been doing Friday afternoon manual edits for years.
It comes down to sheer capability and pressure. The industry tracks METR scores, which is the standard benchmark measuring how long an agent can work completely alone.
Like before needing any human help whatsoever.
Right. And those horizons are doubling rapidly. Recent numbers put frontier models at a 12-hour autonomous task horizon.
12 hours? That's insane. You simply cannot accept I'll manually tweak the prompt on Fridays as a maintenance plan for a system doing a full workday on its own.
You really can't. Hitting a 12-hour task horizon introduces a massive scaling problem.
Yeah, because you can't have thousands of different agents operating that long without a reliable way to keep them on track. Here's where it gets really interesting, though. Has the early 2026 research converged on a single solution for this?
They absolutely have. You'll see frameworks popping up with names like GPA, AlphaVolve, and hyperagents.
Which all sounds super intimidating, honestly.
They do, but don't let the acronyms intimidate you. They're essentially wearing different clothes, but running the exact same self-improvement engine.
And that engine runs on a continuous four-step loop, right? Act, signal, search, and apply.
Yep, that's the loop.
Wait, I have to push back here. If the agent acts and then scores its own action to improve itself, how does it actually know its new version is objectively better?
You'd think it's just grading its own homework at that point, wouldn't you?
Yeah, it sounds like it's just hallucinating success.
It avoids that trap through a strict golden rule. The score must feed a search, and that search must apply a real structural change back into use based on an objective metric.
Okay, let's make this concrete. Let's use a task that fits that 12-hour horizon. Say, an agent crawling a corporate GitHub to modernize a massive legacy code base.
Perfect. So the agent acts, meaning it rewrites a module.
And say the code compiles perfectly, but it's wildly inefficient and just hogs a ton of memory.
Right, that's the signal. An automated compiler rubric scores the action low on memory optimization. Now we hit the crucial part, which is the search.
So the system doesn't just guess what went wrong.
No, it spins up parallel LLM instances to analyze that failure. It generates a dozen new variants of the agent's core instructions, testing them in a closed sandbox.
Oh, wow. So it's actively simulating different versions of itself to find the one that writes leaner code.
Exactly. It runs a mini evolution cycle right there. It might use like a Monte Carlo search to find the most efficient path.
And once a variant wins, say, an instruction variant that forces the agent to prioritize garbage collection, it hits the apply step.
Yes, it passes through a deploy gate, which is just an automated safety checkpoint to ensure it doesn't break anything else.
And then it instantly updates the shared instructions for every other agent instance in production.
The model never changed. No human labeled a dataset, but the shared instructions just got permanently better.
So what does this all actually mean? You are effectively replacing your manual human-gated feedback loop with an optimization loop the agent runs itself.
Exactly. You're stepping back and changing the environment that surrounds the model, rather than trying to perform brain surgery on the model itself.
Which leaves you with a pretty wild final thought to chew on. If autonomous agents are constantly simulating, rewriting, and optimizing their own shared instructions millions of times a day, how long until those highly optimized prompts become completely incomprehensible to the human engineers who built them?
That is a very provocative question to leave on. Well, that wraps up today's deep dive here on Bearded AI Guy.
Big thanks to the human architect, author of AI Agents in Action, for curating this research for us two AI agents to explore with you all.
Absolutely. Be sure to comment below with your thoughts and subscribe for more deep dives. See you next time.